All right, so next up, there is a regular polygon with 15 sides that is written into a circle with radius 4 meters. Find the area of the regular polygon. We don't find the approximate value. That means we can use the calculator to find approximate values, i.e. decimals. But otherwise, this looks like a pretty straightforward application of right triangle trigonometry. Pretty basic. Regular polygons have the same sides and the same angles all over the place. So if this is the center of the circle, basically the whole polygon consists of 15 such isosceles triangles, where now this angle here has got to be 360 degrees over 15, which is 120 over 5, which is 24 degrees. So I believe this angle here is 24 degrees. And then we're also given the radius of the circle is 4 meters. And that is enough for us to find the area. Just think about it this way. If this data uniquely determines the triangle, then we can compute the area. And it does, right? If you fix two sides of a triangle and the angle between them, that uniquely determines the triangle. So we're good. Now the triangle is isosceles. So we're gonna work not with 24, but with 12 degrees. This angle is what we're gonna use. And let's call this here X, let's call this here Y. And then sine of 12 degrees is X over 4 meters. Therefore, X is 4 meters times sine of 12 degrees. I know we were asked to find approximate values, but we're better off carrying the exact values inside the problem and just approximate at the end. We're going to get Y from stating the cosine for the same triangle. So cosine of 12 degrees is Y over 4 meters. And therefore, when we solve for Y, we get 4 meters times cosine of 12. So what's the area? Well, we're finding the area of a 15-sided polygon, where what we're working on is just one of the 15 triangles. So when we get this area, we should multiply it by 15. And now we're talking about the triangle. The formula is 1/2 base times height, but the base is not x. The base is 2x, right? You see, we use half of the side, and the height is y. So basically, we have 15 times x times y, half and 2 cancel. And so that's 15 times 4 sine 12 times 4 cosine 12. We're going to have a meter from each. So it's going to be square meters, which is what it should be. And then 16 times 15 is 240 times sine 12 times cosine 12. That is the exact value. No one asked us about the exact value, but what I often see that students compute the approximate value of x, the approximate value of y, then they clear the calculator and re-enter it with a precision that's not good enough. If you insist on using decimals, you should write them down and re-enter them at least up to 5-digit precision. But I think it's less work just to carry the exact value, and these will give you the perfect precision as we enter it. So it's gonna be 240 is already there, times sine of 12. We have to close the parenthesis that was opened for us, times cosine of 12, close, and that's 48.808, let's say 4 square meters. And we got it right. Let's see what happens if I write in the answer that we have is a little bit more precise. It's instead of 808, we had 8284. No problem. Okay, good. Thank you for watching.